Hello everyone and welcome to the second in our tutorial series on Object-Orientated Programming. Object-Orientated Programming is of course when programs are written in terms of objects and classes, and this differs from procedural or functional programming where programs are written as a collection of functions or modules. Previously we learned that objects are unordered collections of properties, meaning data, variables, also sometimes called fields, and or methods, by which we mean functions. Properties are things an object has, for example name, age, height and weight, whilst methods are things that an object can do, for example run, walk, fly, swim, etc. We also learned that we can create blueprints for objects called classes, and that objects can therefore be instances of a class. And when an object is created as an instance of a class, it is said to have been instantiated. As an example of objects and classes, Lassie is an instance of the dog class. There are many dogs, but only one Lassie, and this is the correct relationship between objects and classes. If this all looks a little daunting, check out the previous video in this series, where I cover these concepts in much more detail. However, if you are comfortable with these concepts, we will carry on and look at inheritance. Inheritance is when one class inherits properties and methods from another class. The inheriting class is called the subclass or child class. The class which is being inherited from is called the superclass or parent class, and a subclass is a more specific version of the superclass, which will become clear as we look at some examples. Here are some examples. Honda is a subclass of the car class, dog is a subclass of the mammal class, and surgeon is a subclass of the doctor class, and so on. In each of these examples, car would be the superclass of the Honda class, mammal would be the superclass of the dog class, and doctor would be the superclass of the surgeon class. We can see that surgeon is a more specific description than doctor, and that dog is a more specific description than mammal. Though more specific than its superclass, a subclass is still not an object. In our last slide, we had the example of Lassie as being an instance of the dog class. Lassie would be an object, a specific instance of the dog class, which is a subclass of the mammal class, because there is only one Lassie, but there are many dogs and many mammals. Also notice in this example that the dog class is a subclass of the mammal class, and the mammal class is in turn a subclass of the animal class, and this shows that it is possible to have hierarchies of classes. In this example we have two classes, the animal class and the person class, and then we create an instance of the person class called person. And in this example the animal class has the properties height and weight, and the person class has the property name, but the person class extends over the animal class, and this means that instances of the person class will have both a name and a height and a weight. The use of the extends keyword is common to most object-oriented languages which support inheritance. Looking at this example in diagram form, we can see that we have two classes, the animal class and the person class, and that the animal class has the properties height and weight, and that the person class has the properties height, weight, and name, with the height and weight properties being inherited from the animal class, which the person class extends over. In this diagram, we can see a hierarchy of classes with the animal, mammal, and human classes arranged by inheritance. We can see that the mammal class extends over the animal class and inherits all of its members, as well as having some of its own, whilst the human class in turn extends over the mammal class, inheriting all of the members of the mammal class directly, and also, therefore, all of the members of the animal class indirectly. Here we can see a more complex hierarchy, where we have an animal class, which has the subclasses reptile, mammal, and insect, which in turn have subclasses for snake, crocodile, pig, sheep, ant, bee, and so on. And we notice that in this hierarchy of subclasses and superclasses, the trend is one from general to specific. Animal is a very general description of an object, whilst human is a more specific description of an object. Subclasses have a is-our relationship with superclasses, not a has-our relationship. Has-our relationships can be established by having an instance of a class be the property of another class. Classes which have a has-our relationship with each other are sometimes called composite classes. And here's an example of a composite class in pseudocode. We have three class declarations, engine, steering wheel, and car, and then we create an instance of the car class called myCar. If we look at the engine and steering wheel classes, we can see that they have their own properties and methods, which I have left blank for now. And if we look at the car class, it has a steering wheel property, which is an instance of the steering wheel class, and an engine property, which is an instance of the engine class. But there is no inheritance here because none of these classes have an is-our relationship with any of the other classes. The car, engine, and steering wheel classes are related to each other by has-our relationships. A car has a steering wheel and a car has an engine. There are no is-our relationships here, as a car is not a steering wheel and a car is not an engine. In some programming languages, there is an object class from which all other classes inherit. And in such a programming language, we can see that the animal class would inherit from the object class, as would the engine class and the car class, and the reptile and mammal classes would inherit from the animal class. Notice again that the car and engine classes are not related by inheritance. They would both inherit directly from the object class. Some languages allow multiple inheritance, where one class can inherit from many other classes. In this example, the icon class inherits all of the members from the image class and all of the members from the button class. Some of the advantages of inheritance include that inheritance allows us to create many different classes with far less code. It allows us to arrange classes in hierarchies. And other advantages are that it allows us to make use of method overriding, and we can use it to enforce polymorphism, which are two concepts we will be looking at in subsequent videos in this series. As always, if you've enjoyed this video, please rate, comment, subscribe. And if you have any questions, comments, or criticism, please comment and let me know, and I will try my best to take on board your feedback and see if I can do better next time, and hope to see you there.